Hello, everyone. Well, this is our selected group of students. Welcome to everyone here. It is my great pleasure to introduce you Professor William Clark. He has just arrived from his university and is going to be here with us this morning and this afternoon. Professor Clark is a Harvey Brooks Professor of International Science, Public Policy and Human Development at Harvard University John Kennedy School of Government. He is a well-known specialist on sustainability science and has been advancing this new type of knowledge for quite a while. It's particularly important for you, students of this course, because we have been trying to introduce you to this new field or approach to knowledge. And now I am not going to use much time because I think that the best way to use the time is leaving you the floor for your lecture. And we will stay here until 12:30. This lecture is going to be recorded and make it free available in the internet in the near future. So welcome, Professor Clark.
Thank you. Okay, so I'm delighted to be here. I want to get a little bit of a feeling before I start as to who you are and what directions you're coming in. So since we have a limited number, can we just quickly go around and say who you are, what part of the world or country you're from, and which discipline you're pursuing, so I have some feel. So can we start here? Yeah?
My name is Awirani. Oh,
Talk loud.
my name is...
Sorry, we'd like to use this
Oh,
and pass it on.
My name is Awirani. I'm from South Africa, the University of KwaZulu-Natal, and I'm in the built environment.
good.
I'm Ayeni Benjamin Unuropu from Nigeria. I'm studying in University of KwaZulu-Natal, South Africa, and my discipline is social work.
Okay.
Yeah.
Hello, Professor Clark. My name is Denford Chipongose. I'm from Zimbabwe. I'm reading my PhD at the University of KwaZulu-Natal in South Africa.
Interesting.
Hello, Prof. My name is Lawrence Ogunsonya. I'm also from the University of KwaZulu-Natal in South Africa. My area of expertise is architecture, and my PhD is in city planning.
Thank you.
Hello, my name is Anastasia. I'm from Russia. I'm actually from natural science. I study ecology and especially carbon cycle in boreal forests.
Excellent.
Hello, I am Carla Arevalo. I'm from Argentina. I am working in economic development and especially poverty and inequality.
My name is Patrick Hosia, a Nigerian from the University of KwaZulu-Natal, South Africa. I'm in political science, and my PhD is on climate change and security.
Thank you. These guys.
My name is Diana Suarez. I'm from Ecuador, and I have been related with the public policies and social science field.
Hello, I am Sutandra Singha from New Delhi, India. I am currently pursuing PhD from Center for Asian and Central Asian Studies in Jawaharlal Nehru University, and I belong to the background of geography. Thank you.
Hi, Prof. My name is Jablane Nyao from South Africa, within the University of KwaZulu-Natal, from the discipline of public governance.
Hi, Prof. My name is Isaac Kambule. I'm from the University of KwaZulu-Natal, and my interests are in international political economy and international development.
Hi, Professor. I'm Binod Adhikari from Nepal, and I have currently done my master's from University of Bergen here.
I'm also Portia Dadi Williams. I'm a Ghanaian from West Africa, but I'm studying at University of Cape Town in South Africa. I'm with the Environmental and Geographical Sciences.
Thank you.
Hi, my name is Haptamu Tadela. I'm from Ethiopia, Mekelle University, and I'm studying climate change and rural development.
Good morning. I'm Catherine from the Philippines, and my PhD program is on development studies.
Thank you very much. Okay, that makes it a little easier. Since you all come from obviously the same place in the same area, no trouble providing focus. Okay. Is there something I should be clicking to make these things change, or I just lean over and do that? Okay, so what I want to get us actually involved in a discussion today is the following problem. I want you each to think of the most important thing you've learned in the course of this summer school that you might actually find useful or hope you could make useful in changing the way the world works, in improving it somehow. If you could just take this lesson and take it back into the world from which you come and argue with policymakers or business leaders or civic leaders and say, this thing I now know, you should believe it and you should do something with it. So pause 1 minute and think what that is, because you're going to need a specific example that makes sense to you for this discussion to have any place to go. So 30 seconds, think about it, best if you write it down. Most important thing you've learned that you think if you could just get other people to believe it back home, the world would become a better place. 30 seconds, write it down. Okay, so getting a little ahead for people of my age rather than yours, this is sort of what we spend our whole lives doing, is you discover things or you learn things from your colleagues, and because of what brings us to a summer course like this, or me, an ecologist studying carbon cycle that now works in the School of Government at Harvard, you try to take those ideas and make them useful in the real world. Make them something that somebody in business or government or civil society can do something with. So here's the problem. Why would anybody that is out in the outside world, anyone outside this classroom, believe this idea of yours enough to risk their livelihoods, the future of their families, in many cases even their lives, on believing that what you say is true? Why should they think that this stuff that we as researchers discover or learn from one another is worth betting their lives or their businesses or their children's health on? So take the one fact, the one idea that I asked you to write down, and think a bit of who the most important or influential person that you could try to convince this is true and they should change what they do, business, government, civil society. How would you argue with them? Trust me, do it this way, believe this thing, rather than what you do right now. And, you know, I started out my career as a systems ecologist, measuring stuff and eventually getting into the policy side of it, so doing public policy and so on. And those are really complicated areas. But it has turned out for me, the hardest work I do is addressing that question, not the very difficult work of discovering something about the real world that I didn't know before that is potentially useful, but getting other people who are responsible for running government offices or businesses or households and have all sorts of people telling them, believe this, do that. Why should they pay any attention to my expertise? And I've worked on these sorts of problems. The background reading I gave you, I've worked with those colleagues in Kenya, in Uganda, in Indonesia, in the far reaches of the Amazonia, in Brazil, Peru, worked in my own country, worked in northern Canada on these issues. And after many, many years of discovering how much I had learned about, I think by now being actually pretty good about arguing with people about why they should believe some of this expertise that we all learn, that this was nowhere written down, that it was nowhere part of the training that you or I got as graduate students. We all had to learn it by making terrible mistakes, wasting all sorts of time. And so my colleagues and I gave ourselves the following assignment. And you'll have noted my colleagues, one works in University of Chiang Mai in Thailand, one is Australian, one comes from Argentina. Pretty international group with about 150 years of experience behind us. And we said, if there were just 4 things you could tell your students about what you've learned, about how you make your knowledge usable in practice, what would those 4 things be? And then, though I won't focus on it here, if you had 4 things you could do to reform the institutions that are giving training to our students in order that they would learn some of these things in the classroom rather than having to learn them by trial and error and practice, what things would you do? So 4 things to know, 4 things to do. Basically the answer to what can you do as a researcher to making your technical knowledge more usable in the world of practice. And for those who read ahead in the reading, the case I'll make in the larger lecture this afternoon is that for those of us who study in the sciences, social, natural sciences, engineering, health sciences, in order to promote poverty alleviation, sustainable development, improving people's livelihoods, we are not the people on the front lines of political reform. What we're trying to do is provide useful information to the people on the front lines of political reform, what the Nobel Prize winner Amartya Sen has called informed agitation. That is, make it that the people in business, in government, out on the streets, who are arguing and pushing politically for reform, have actually useful facts in their hands. The challenge is that too many of these agitators, the people out on the front lines of reform, need useful information that we as researchers aren't giving to them. We're focusing on other questions that our peers in the science community think are really exciting, but we aren't listening particularly hard to what people on the front lines of action need to know. Reciprocally, too many of the discoveries we all make, we and our colleagues make, that might actually be useful if they could be moved into practice are ignored because we haven't answered these questions of why anyone would believe us. So one way forward for researchers to do better, as I've said, my colleagues and I have tried to distill all of our blunders and mistakes through the years into these 4 things to know and 4 things to do, which is what I want to talk with you about. That diagram is from the longer paper that was provided as background reading. I'm going to focus on the top one, what you need to do rather than what you need to know rather than what you need to do, simply because what you need to do, much of it is about how you would reform a university, how you would change the degree requirements, or what we taught in summer schools. And I realize that for at least some of you, that may be 1 or 2 years off before you get to change universities. So I'm going to focus on the top one, which is what we might know, but I'd be happy to go into the other one, the university and other reform agendas for the institutions we work in at the end. Okay, so as we argued in the paper, the biggest deal, the biggest insight, is to understand that we can only slightly separate the world of actionable knowledge, that is, the production of knowledge we hope will be useful to somebody, from the world of knowledgeable action. That is, from action in the real world that is taken by people we hope are informed, know what they need to know about agronomy or social justice or architecture or climate change. That these two are very closely coupled. They are not separable. We cannot break off what we do in the laboratory from what they do in the boardrooms of industry or the parliaments of government. And let me give an illustration of something that looks like a technical decision from our community, but turns out to be all full of politics. Way back in the 1950s and 1960s, when finally the international community was beginning to try to help fund technical work out there in the world that would improve people's lives, one of the big challenges, of course, was getting adequate control of water. Stop rivers from flooding and killing people, harness rivers to provide irrigation, electrical power, and the like. And so, as you all know, we went rapidly down a trajectory of building many of these very large dams. Just from where you've said you're from, many of you are right in the middle of large dam building projects. And those have generated lots of good things, but also lots of bad things. Most particularly, though, what our decision, largely as a technical community of engineers and economists, our decision to serve water needs by building very large hydroelectric dams, rather than building lots of very small generator units that could be put on side tributaries, on run-of-river operations, and so on, has meant that if you once decide to build big dams, you are automatically saying that more power will go to those in the ministries and the businesses that are involved in building big dams. And the power will go away from local communities that might choose to harness their own power, to take loans from World Bank, to put small couple of kilowatt generating stations on local rivers, and so on. You basically build up the authority of national government structures and international lending operations instead of, with your technical decisions, going, which would have happened if we had emphasized the building highly efficient turbines and small microloans to put those into communities. Those would have empowered not the World Bank and large businesses and governments, many of whom, in my country at least, have been corrupt, rather than empowering them. Our technical decisions resulted in empowering some big political actors and disempowering local communities, many of which were simply moved out of their places of home to install these things. Second example, back in the 1980s, when I was a graduate student, doing global environmental issues. We found the most exciting thing imaginable was we were finally beginning to track transboundary air pollution. That is, pollution that would be done in your country, would go up, have chemical reactions in the atmosphere, and come down 1,000 kilometers away, often in somebody else's country. For Europe, that was acid rain and acidification, in which Norway was hugely affected. But we see the same in Indonesia's biomass burning, landing on much of Southeast Asia and the like. We were fascinated with this. We said, gee, this is a transboundary issue. We now understand the science of it. We will push that science to help build international treaties, which we did on ozone depletion, on acidification, increasingly on toxic metals like mercury and the like. And these were all good things. But what happened? They also, by pushing in that direction, saying that the most interesting science we have about long-range pollution is this transboundary character, we helped empower a whole generation of lawyers, I realize I'm in a law school, and political activists to build a focus on international treaties. And so endless UN meetings, negotiating these very complex ozone agreements, transboundary air agreements, and so on, probably a good thing. But as we're now discovering with the climate change agenda, what that did, by saying all these issues are transboundary, is they took responsibility away from local communities and states to deal with their own problems, to take on their own reduction of emissions, and even more important, as we see now in the climate debate, to begin strengthening their own societies to be resilient and robust in the face of the kinds of damages that were going to occur to them, whether our treaties went forward or not. So again, by pushing the science of the transboundary character of these problems, we undermined the authority and responsibility of local communities, often of national environmental authorities, to build staffs and policies focused on robustness, resilience, and so on of their local communities to how they would deal with the effects of pollution. No one intended that as an evil or bad thing, but it is simply to give the second illustration, along with the hydropower one, that what we choose to do as scientists and researchers and engineers has huge implications for who gets more power, the international community, the World Bank, and so on, who has their power and authority undermined, local communities and the like. Now, I could do reverse stories, but these are two big ones in which we scientists, thinking we were doing nothing but good, turned out to empower one group of actors and disempower others that we had no idea was even part of the consequences of what we were doing. So if one once understands that knowledge and power are co-produced, jointly shaped by one another, the powerful interests are the ones who pay for our research, therefore we research the topics they're interested in and tend not to research the topics they would find social justice topics, migration topics, to be hostile to their interests. So what do we end up doing? As well-intended researchers, we end up doing a lot of research, good research, but on questions defined by the existing power structure because they have the purse strings. They're the ones who give us fellowships and send us off to summer schools. What stories don't we study unless we are really courageous and have good supervisors and strong institutions behind us? The problems of the poor, the disempowered, the ones who have no money to pay the research bills, have no power in parliaments or industries to fund the work that would most improve the lives of the disadvantaged. Okay. So what can we do about this? Not too much, but something. So we point out in the paper our answer to the 4 things you need to know in order to navigate this complicated area of the link of research and power more closely. First thing we need to know is that whether you're an engineer or not, when you're doing research that has implications for the real world, you are involved in an innovation system. It may be innovation of ideas, of devices, of policy, but it's innovation. And what that means is that a little bit of its value in the world will come from the initial idea you have, but a great deal of whether that idea turns out to be useful or damaging, or who it empowers and whose power it undercuts, comes from how that works out in practice, and how practice then shapes back in the next iteration. An example, the first Green Revolution, so late 1960s into the 1970s. I think one of the most heroic periods in at least my memory of natural scientists, agronomists, eventually agricultural economists from all around the world coming together to say, we need to pool our efforts and resources not to advance individual countries, but to advance the lives and livelihoods of poor farmers, mostly rural farmers in the poorest parts of the world. And people left tenured university jobs, volunteered their work to go to the international agricultural research centers, produced a lot of good stuff that has kept hundreds of millions of people from starvation and hunger. But, linking back to who set the agenda was set based on the things we already knew how to do, and thus could do better, which was the core crops of wheat, rice, and maize that were the mainstays of roughly Europe and North America and Australian agricultural efforts. Now, those fit pretty well with what was needed on the ground in much of Southeast Asia, in parts of Latin America, but it almost entirely missed the kind of crops that were most needed in Africa. You will know more about this than I. It's not that maize, especially to a certain extent wheat and a little extent rice in some areas, hasn't been useful. But in no sense did the Green Revolution focus on the question, improvements in what crops does Africa need most? And that's because Africa was hugely underrepresented in the international groups, even very well-intentioned, of the Rockefeller Foundation and others, who came together to try to think, what could we do? Even more so, and this was in all countries, the crops we invested in making more efficient, better users of water, better users of fertilizers, were by and large the crops that experienced farmers and agricultural scientists in the West cared about. What we did not do in the first Green Revolution was go out into the field and talk to farmers around the world on what they most needed improvements in. What were the threats that were most damaging or most scary to them in terms of next year I may not be able to feed my family? What could research do not for our problems, but for their problems? And so, large segments of the world were left out of the Green Revolution. Large segments of the world got into the Green Revolution, but into a pattern of indebtedness to buy fertilizers and irrigation and so on that we had not fully thought through. And though, again, the successes were many, if any of you are able to invent a next Green Revolution, that would be a really good thing to do. But what we have learned is that it had real limitations by taking the agenda from the established international network and not going out and consulting with people in farms about what kind of innovations they needed. Second Green Revolution, the second round, the so-called Evergreen Revolution, has tried to take those lessons to heart. So in the international agricultural research centers, the national agricultural research institutions, and so on, we see much more of a commitment to working not from the top down, but up from what farmers see as their greatest needs, the largest constraints, not necessarily on making profit, but on keeping their families safe. And then on top of that, the largest opportunities for generating disposable income and letting them start moving up the development ladder. That kind of lesson is certainly not something that when I was studying parts of agricultural science and forestry and fisheries, nobody talked to me about that stuff. Nobody talked to me about where do you get the question you focus your research on? I got it from reading journals and talking to professors, not from going out into the field and talking to the farmers, the fishermen, the loggers, the health officials who were trying to advance action on the ground. And I'm not saying that those people have the only insights that are worth shaping one's research, but I am saying that I think we've slowly learned innovation. I mean, if you were in a business community and worrying about innovation, you would never dream of pushing innovation without going and talking to the customer who you thought might ultimately buy your new device. We're slowly learning that that really is the game we're in, whether we're going to sell it or give it away when we're doing research that we hope will improve the character of the world. So it's an innovation process, not just for the engineers, not just for the policy people, for all of us. And just like any innovation process, we've got to be thinking of what the customer needs, the person we're trying to help needs. And we've got to be thinking about the full system of other supporting innovations, road networks, power grids, or whatever, that are going to be required if our one little idea is to have any chance of beating out. So as we think of, but I'm discovering this thing, the question we need to be asking ourselves is, what other things does somebody have to have discovered in order for that thing to be useful? Here in Norway, in my own country, we're facing this in a way that is not life-threatening at the moment over the penetration rate of electric vehicles. So electric vehicles are a really good idea for congested cities for all sorts of reasons. And the problem is not right now making electric vehicles more efficient. That is happening very fast. The battery technologies are improving really quickly. The problem is they require charging stations. And all the refueling stations we have are built around the fossil fuel network. And it isn't just a matter of running a power cord into these stations and saying, okay, now plug in your car instead because the recharge rates are too slow and so on. So we're actually being bounded in our ability to, say, relieve urban air pollution with electric automobiles, not by the brilliant ideas that the car makers are having, but by the more mundane stuff of thinking how I build in competition with the existing infrastructure of petrol filling stations, how I build the set of networks, who's going to pay for it, who's going to get paid and earn money through it, of a system of charging stations around the world. Okay? And that kind of uptake happens in public health. We invent a new vaccine, but we don't think through that this is a vaccine that needs cold storage. So you have to have inventions in an ability to maintain cold storage all the way out to the most remote villages. How do we do that at a scale that can be transported and is robust to failure, and so on and so on? We have to think, what would my knowledge need to couple with somebody else's knowledge in order to produce useful products? That's innovation. Second thing is we need to understand that when we move out of the laboratory, where your program directors just told me that they had been gently discussing with you the problems of single dependent variables and controlled independent variables, or maybe everything's connected to everything else and you're in deep trouble as a researcher. Okay? The answer is, in the real world, we're in deep trouble as researchers. Things are connected to one another. What we understand now, we barely did when I was a graduate student, is that as we try to intervene in these coupled social environmental systems, whether it's in farming or forestry or health or global environmental change, we do something. Take, for example, London in the 1700s and early 1800s. Rapidly growing city. The entire approach to disposal of human waste was to bury it in your backyard or to throw it out the window and dump it in between houses. This was obviously, as London got denser and denser, multiple millions of people, becoming a real problem. So smart public health innovators said, great, what we'll do is require that everybody have a cistern, a water closet, a toilet, and connect that to a pipe that would just dump into the river. So we get it out of people's backyards. Brilliant solution. Cleaned up backyards wonderfully. What they neglected was that the same river was the place we were getting drinking water from. And so what we managed to do was take everybody's waste, and instead of percolating it down through the soils in the backyard, we put it into the river. We pulled the same water out of the river and immediately started having huge cholera outbreaks, lethal mortality in these cities, and so on, that persisted for decades until public health engineering caught up with the notion that you had to separate where you disposed of the wastes and so on. So it was a complex adaptive system. In the United States, we are just coming out of a period where people like me were really enthusiastic advocates of biofuels as an alternative to fossil fuels to run our economy. We did a lot of research on which biofuels, which grasses, which trees would provide really high density energy. We felt so proud that we got the government behind this, and so we got subsidies for biofuels. And the farmers, who usually are our enemies, were really enthusiastic because now they could use their 1,000 hectares of cropland to produce not maize at market prices, but to produce fuel at market prices. So they were just happy as clams. So this system got moving and moving, everyone trying to do the right thing, until we discovered that the net pollution effects of biofuels, when you produce them from American crops and forests, are no better than fossil fuels. They generate net about as much greenhouse gas pollution, so as much climate change. They generate different kinds of air pollutants, that damage people's healths, but about as much. If you're a Brazilian and you're building biofuels off of sugarcane that is naturally irrigated, you are in heaven. This is a great thing to do. It's incredibly effective and efficient. But by casually saying, we can do that in North America with irrigation, fertilizers, and so on, it turned out we blew it. We made a big mistake. So we said, okay, we're scientists. We can admit mistakes. We'll go back and change it. So what happens? We're connected to a political system. All these farmers who were now getting subsidies to grow biofuels said, no, you're not going to take this away from us. We produce biofuels. We're helping to save the world. But we said, but it's not saving the world. It's killing people. And they would say, sorry, that's our subsidy and you can't take it back. And ever since then, we have had in every presidential election, no presidential candidate will go forward and say, I'm going to remove the biofuel subsidies, which are essentially subsidizing killing people, for a technology that good, well-intended environmental scientists like I helped advance. It's a complex adaptive system, and when we don't think through beyond the first step, the implications of things, we end up making blunders. The lesson is not that we can ever get smart enough not to make blunders, but we need to think really hard about the social systems we plug these into so that just as good experimentalists in the laboratory, when it turns out we did the wrong thing, we can learn from those blunders and change them and understand that we don't want to let things get put in place so quickly in ways that build big political constituencies behind them, as the biofuels did, so that our pathway to admitting error and backing up is wrong. So complex adaptive systems mean whatever brilliant discovery you make, or even semi-brilliant discovery you make, with the best of intentions and all your lab results and your first field trials show it will work well, when it's put in place in the real world, it's not going to work the way you thought it did. And if you're really lucky, it'll turn out to work even better and have all sorts of cool implications. If you're not lucky, it'll do some good things, but it will also have some really bad things. And the notion is not don't do it. It is that we have to pay a lot more attention to treating our interventions as scientists, the ideas we come up with and put into the real world. That's an experiment in itself. And we have to spend as much time and energy worrying about monitoring what actually happens in the world after our new technology, our new idea gets introduced, and making that feedback something that not just us, but society at large says, oops, that had some downsides we didn't know about. And yet, for those of you who have found yourself in the grant writing business, you know that the hardest thing to get anybody to fund is monitoring and evaluation of the long-term social implications of your new discovery. They'll fund your research and they'll fund your field trials, but once you say, yeah, this did increase crop yields, or yes, I can use switchgrass as a biofuel, they're done. No one wants to fund these long-term social feedbacks that would be necessary were we to fully address the issue that these are complex adaptive systems that we're intervening in. Okay. So let me come then to the adaptive part. I guess I jumped over that. Adaptive, you often hear people talk, as I just have carelessly, about complex adaptive systems. Systems can be complex without being adaptive, just lots of moving parts and so on. The adaptive part is that, contrary to what multiple regression experiments would suggest to you, once you get enough data and got the coefficients estimated, they don't always stay the same. Somebody finds out that you're making a lot of money by your new intervention. They will now build more capacity to provide the same thing. And suddenly the coefficient of your regression, which was essentially the profit one, goes down. Why? Because people have adapted to your wonderful success by jumping into the same market. Which means you better be changing what you're doing. Any businessman knows this, but most scientists don't, because the very success of your initial innovation is going to lead to its diminishing returns. Take this to a very practical issue. One of the great success stories of the last decade has been really huge progress in dealing with malaria around the world. Not just by the old North American and European approach of draining wetlands, but by actually putting in place systematic regimes that separate people from the mosquito, from the parasite. And the operation of distribution of bed nets for free or at very low costs, coupled with the education in what are the hours of the day that your kids need to be under the bed net, and so on, has turned out to be one of the greatest, most efficient life-saving technologies since antibiotics were invented. Now, the problem is that the way public health officials and bed net engineers, brilliant folks, designing these incredibly inexpensive but very effective bed nets, they forgot two things. That is, they didn't think about these as adaptive systems. So the first answer was you put these bed nets in and decide that they should, kids should be under bed nets. Anybody should be under bed nets from dusk until dawn. Give you a couple of years and natural selection means the mosquitoes have figured this out. And mosquitoes that used to not come out until after dusk now are coming out 2 hours before dusk. And the mosquitoes have adapted, but since we weren't watching for this, the instructions about when to use the bed net didn't. And in fact, who can afford to cut 2 more hours off their working day if you're pushing subsistence farming? You can't. So it turned out the bed nets were great as long as they were simply saying, after dark, when you're not working in the fields anyway, get in under the bed net. They were no good when the mosquitoes evolved to come out earlier precisely because the bed nets were so effective. So we're gonna have to figure out some other interventions to keep people and separate. Still, bed nets were better than nothing, except the other thing that adapted, which was people. Bed nets were now all over the place, not freely available, but they were available. People, enterprising individuals, discovered amazing things you could do with bed nets that had nothing to do with mosquitoes. You could use them as fish traps. You could use them as netting to dry crops in. And suddenly we started finding, as we went back and did location level, so village level evaluations of how well the bed nets were doing at keeping people and mosquitoes separate, was that the bed nets were gone. Not gone from the community, but gone from the beds, because they were being so useful as fishing nets, as nets, as things to carry material to market were. And that in all parts of the world, including the southeastern part of my own country. And again, nothing was wrong with the concept of a bed net. What was wrong was figuring that mosquitoes and people would continue to react to their presence the way the designers thought they would, when in fact, successful organisms, mosquitoes, successful people, have always said, well, that's a different that's a different rule of the game. I could do something smart with that. And suddenly the smart thing they do means that whether it's evolved insecticide resistance or figuring out you could do different things with bed nets or mosquitoes changing the time of day they fly, because the balance between being predated on by birds versus being having access to your prey had shifted. We've got, what do you need to do as an intervener, as a researcher, is think ahead as to how this system will adapt to your original discovery, if your discovery, once you convince somebody to pick it up. And again, begin thinking of adaptive responses and behaviors. So finally, and this links back to where I started, that, speaking for myself at least, but maybe for many of you, the choice to go into research rather than into active politics or community organizing was for many of us because we found active politics and community organizing and so on really uncomfortable. And we thought I could take several steps back from that and do social good by research rather than social good by being out on the barricades. Well, it turns out that's true, but that, as my early examples on the hydroelectric stuff and the long-range transport climate models or atmospheric pollution models showed, nothing we do in the laboratory in the universities, once it begins to poke its nose into practice in the real world, is other than a political statement. Every single thing we do that is not just pure theory, and we of course never know when it will be pure theory or suddenly find an application, has implications for the old adage that says knowledge is power. It will help some people become more powerful, and it will undermine the power of other groups. And there are many examples. One I am still involved in that we talk about a little bit in the paper is work in rural Indonesia, where we've been working with the concerns that some of the poorest, most politically marginalized people there have been pushed up into the hills. That's the least productive real estate. It's where you go if you don't have money or power. Well, they're doing swidden agriculture, slash and burn agriculture. One of the consequences of that, people downstream say, is, well, there's a lot of silt in the rivers. The silts clog up the hydroelectric plants. They clog up the water provision in the cities. And so the cities don't want it to happen. And even 10 years ago, the response to that was periodically the cities would send soldiers up into the upper forested watersheds, and they would arrest, deport, kill off the people there, literally. More recently, it's begun to understood that this is a partnership, that the cities could pay a small amount of money for them to incentivize the upstream forest users to do their swidden agriculture on less steeply sloping areas, to adopt agroforestry approaches that were less damaging to erosion, and so on and so on. But the question was, what would be a fair price? And lo and behold, they call on scientists to measure erosion rates, how much the livelihood of upper slope people could be improved by small cash transfers, what it was worth to a downstream operation to not have to clean the filters on its hydroelectric plants and so on so often. And so silly people like me get involved in trying to do these because nobody trusts the local scientists because they're all hired by the government. Many of them are great, noble, well-intentioned people, but they do work for the government, and their neutrality in this argument was distrusted. They bring some of us in from outside. The only way a person like me gets trusted in mountainous Indonesia is to team up with groups of people there who have long standing in the community, who are essentially boundary workers, boundary spanners, trust conveyors. And we begin working with them to do these estimates. But what do we find? Is that there is very strong pressure on us from the city governments and the national governments to come out with answers to our research that favor their agendas, that make it cheaper for them, make the upstream people at fault for more of the natural erosion, and so on. We're under huge pressure from the communities themselves, the human rights groups, and so on, to say, look, these small cash transfers from down below are probably the most important thing, other than political citizenship, that these upland hill people could get to begin to move up the development scale. There's enough uncertainty in doing these estimates that you could not help figuring, well, am I going to resolve those uncertainties in the favor of the upstream hill people or the downstream urban people? There was no scientific way to make that split. And so, like it or not, as an independent, would-be trustworthy researcher, you ended up picking sides. And it turned out that if you were a local researcher in the Department of Forestry, you pretty much had to pick the side of the people in power because they paid your bills at the university, they could get you fired, and so on. And those of us brought in from the outside or working in international research institutes, it was pretty much left to us to pick the sides of the upstream, unempowered, poor, often stateless hill people, just because we couldn't be fired by the state. We still had to be fairly careful because we could have been expelled by the state. But it came home, I suppose, most starkly to me in that context, that anything I did, even things like measuring erosion rates, or working at the notion of alternative agroforestry practices and their efficacy in stabilizing soils, that was essentially an inherently political act. And that I had no choice as a researcher but to realize that the topics I chose to research, large dams versus small head hydro, transboundary air versus local resilience in the face of pollution, or in this case, the siltation rates coming off hillsides in Indonesia. The very choice of what problem to look at, much less my interpretation of the uncertainties and so on, was an inherently political act that benefited some and undermined others, and that using those, taking that political alignment of my work as seriously as I took my choice of topics, that's a good research topic, that's something I could bring data to bring on, that's something that you actually might make progress in understanding. Those were equally important parts of what I do. So, as I say, that brings me to the end of this. The slides will be up and published. I do a similar thing for, okay, if that's what we need to know, how would we restructure our universities and training programs and summer schools in order to help us know it? Is the best time to introduce folks like us to this the way you're getting it in the middle of your PhD career? Or is there not much you can do with it as a powerless PhD student? Would it be better to do this as mid-career training for people who are already, professors at universities or working in government ministries or in businesses? Should we not be focusing on researchers at all, but focusing on the institutions that do them? I don't know the answer to that. I think it's probably different in different parts of the world. But we talk about those who needs to change what in order to go forward. And what it leaves me with, since I'm talking at a university here in sunny Norway, is if you took a step back and said, great, we've built up some very strong universities around the world based on, to a first approximation, German traditions of the independence of discipline-oriented scholarly research. And that's fine, that does a good thing. But at various stages over the last 150 years, we've reinvented new kinds of universities. We reinvented polytechnic universities in order to serve the needs of mechanizing and industrializing societies. We built public health universities as we began to understand that we had some knowledge that might not be hugely complicated in its own right, but that achieved its significance only when we got it into practice in the world of extending large-scale public health programs. Obviously, we've built medical schools on the same notion. We've built agricultural extension universities on the same notion. The thought experiment I find for me, it's not a thought experiment. The experiment I find myself in the middle of is lobbying for whether we don't need not to replace the classic models of research-centered universities, but to augment them with a set of universities that do for the challenge of sustainability what the agricultural extension schools and the polytechnics and the public health universities did for moving those fields of research into more aggressive and sophisticated practice. And so I find myself arguing with places like Harvard and institutions in Europe as to how we might be different if we built ourselves as universities to advance sustainability, advance agriculture, advance polytechnics, whatever, rather than what we're doing now. And I'll let you know if I find out the answer. But a lot of the learning I do on this comes from folks like yourselves who do remember what my email address was or come visit me and say, I may not know the answer to this whole thing, but let me tell you about the experience in my part of the world as I move up the ladder as a researcher. What I've discovered in the context of my own work is both what does work and what doesn't. So I honestly do invite you. You're experimental animals in this program, and no one else is going to report on the results of the experiment but you, so please do. Thank you.